Okay, in this video we are going to look at cubic functions. So all cubic functions are going to be in the format y is equal to ax cubed plus bx squared plus cx plus d. So like in the quadratic functions, the number at the end of a cubic function tells us where the function crosses the y-axis. So the y-intercept is always going to be at the coordinates 0, d. So that tells us where on the y-axis the graph of the function will cross. The a value here tells us the different types of shapes of a cubic function. So where a is greater than 0, we have two different types of shapes possible. So the first type of shape for a positive cubic function is where we have a traditional increasing, decreasing, and increasing curve. We have two turning points on this curve, and we also have a point of inflection in the center. We can also have a curve, a cubic function, with what's called a saddle point, where it starts by increasing and flattens momentarily and then increases again. What we will always notice about cubic functions, because the highest power of the x is an odd number, you will always have one arm that points down and one arm that points up. If you remember back to the quadratic functions where we have the highest power to be an even number, we are going to look at either a u shape or an n shape, which means that both arms in the function point the same direction. If we were to go further and look at power of 4 functions, both arms would point in the same direction again, where we have a positive and a negative. All right, but that's for another video. But going back to our cubic functions, where a is greater than 0, so where we have a positive cubic function, we are looking at either this type of shape here or a shape with a saddle point. All right, so if then we have a is less than 0, so where we have a negative cubic function, we start off with our two basic shapes. We have decreasing followed by increasing followed by decreasing, or else decreasing with a saddle point and decreasing again. What we'll notice from further chapters when we get into differentiation and calculus, these type of shapes here have two turning points. They have both a maximum and a minimum turning point, whereas these type of cubic functions do not have any turning points, but that's something we'll come across later. So that's your basic shapes of a cubic function. Now, another piece of information in terms of cubic functions is how many roots are possible. Now, because we always have one arm pointing up and one arm pointing down as so, we will always have, cubic functions will always have at least one real root. It will always cross the x-axis at least one point. So we have a couple of different types. So we have one real root, and the graph of this function would look as follows. So we have this kind of possibility here where we have a maximum turning point, minimum turning point, and then it goes up, but the minimum turning point does not come back below the x-axis. We can also have this kind of function here, like the saddle point function that I mentioned, where the point of inflection or turning point occurs somewhere here, but again, it only has one real root. It crosses the x-axis at one point only. So that's one real root. We also have cubic functions that can have two real roots. So in this case, we would be looking at it crosses the x-axis to continue on to its maximum turning point, or minimum in the case of a negative. It touches the x-axis for the minimum turning point and then turns again. So this is where we would have two real roots. Now what happens here is this real root is repeated. So say for example that was a value of 1, this was a value of -3. The roots for this cubic function would be x is equal to 1, x is equal to 1, which is repeated, and then x is equal to -3. Because remember, in order to multiply out and get our cubic function, we have to have 3 roots. But in terms of this one, it's only 2 real roots because this root is repeated. Okay? Then we have cubic functions where we have 3 real roots. Again, we have 2 possibilities for this. We can have our cubic function that crosses the x-axis 3 times, but we can also have a cubic function whose saddle point occurs on the x-axis. In this case, sorry, this would actually be one real root. I'll rub that out. This would be our only option for 3 real roots. Now, in terms of a negative cubic function, we can also have negative cubic function, which crosses the x-axis 3 times, okay? So those are different types of shapes of functions. So we can have an increasing, decreasing, increasing. We can have increasing with a saddle point. We can have decreasing, increasing, decreasing for negatives, and decreasing with a saddle point. We can also have either 1, 2, or 3 real roots. So what we need to look at now is how to actually find out where a cubic function crosses an axis. So we may get questions like that in the exams. So say, for example, I'm dealing with this function here. Y is equal to minus x cubed plus 9x squared minus 26x plus 24. We've learned how to deal with this kind of situation before when we were looking at algebra. We use the factor theorem to determine one of the roots of the cubic function. So we concentrate on this number here at the end, the 24, and we test factors of 24. Now, in the case of this function, if we look at f2, so placing 2 into the function, minus 2 cubed plus 9 by 2 squared minus 26 by 2 plus 24 gives us an answer of 0. This means that x equals 2 is a root of the cubic function, meaning that it crosses the x-axis at x equals 2. To find the remaining roots of the cubic function, what we need to do is find the quadratic factor that gives us our remaining roots. In order to do that, we need to change our root here into a factor. So we bring the 2 across the equal sign to give us x minus 2, and we divide this into our cubic function. Now you can either use your standard long division or you can use the array method as I'm doing here. We put the minus x cubed into the first box. We put the plus 24 into the final box, and we put our linear factor, x minus 2, out here to the side. Dividing in then, we get minus x squared above the first box, minus 2 into plus 24 gives us minus 12. Then we must fill in one of these boxes here to go further. We need the middle term. So we can either fill in this box by multiplying minus 2 by minus x squared to give plus 2x squared. We then look at the original function, and we need these 2 boxes here to add together to give 9x squared, which means that the remaining part must be plus 7x squared, because added together, these give us a required total of 9x squared. Dividing then, x into 7x squared goes 7x times. Finally, all we need to do is solve this equal to 0. Now, because it's a negative x squared, I'm going to make it a little bit easier on myself and multiply across by minus 1, first of all. And then if we get factors of 12, which are 3 and 4, that will add together to give minus 7, minus 3 and minus 4, sorry, we get our remaining roots of x equals 3 and x equals 4. So not only is x equal to a root of the function, we now know that x equals 3 and x equals 4 are also roots of the function. So if we were to write where this function crosses the x-axis, it would be at the points 2, 0, 3, 0, and 4, 0. If we were then to look at the y-axis, remember the 24 at the end, the d at the end tells us where it crosses the y-axis, and that would be at 0, 24. So bearing that information in mind, if we were to draw a quick sketch of the function, we have 3 points on the x-axis. We also have a point on the y-axis. We know that it is a negative cubic function, which means it starts by going down, so it decreases, crosses the x-axis. Our minimum turning point is between 2 and 3. Our maximum turning point is between 3 and 4, and then it's going to decrease again. So sometimes you will be asked to draw a sketch And if you are, that kind of information there is fully acceptable. If you are asked to draw the cubic function, then use the table mode in your calculator. So if we go to mode, select 3 for table, type in our function there, it gives us the points to plot, and we can draw it more accurately. Make sure that you don't get confused between draw and sketch. So that's our basics of our cubic functions.